It's just like coding. It's just like coding. It's just math. It's like coding, but just pure math the whole time. In this video, I'm turning one of the internet's favorite word games into math. For you Wordle purists out there, Connections is another game offered through New York Times' excellent collection of word puzzle games. But I'm not too much of a words guy. These are all like fortitude. There we go. Hard work. No. What? So let's replace the words with numbers. The underlying gameplay won't change. Your goal is still to find 4 connected groups of 4 tiles each, but instead of word groupings, you'll be looking for 4 number patterns, each with 4 numbers to them. I'm calling it patterns. This is patterns. What a fun name. Okay, patterns. There's so many patterns. Math is built off patterns. If you want to get philosophical with it, math is patterns. The language we built ourselves over time to study the patterns of the universe. But if you don't want to get philosophical with it, there's arithmetic patterns, there's geometric patterns, there's Fibonacci sequence, there's Pascal's triangle, there's patterns and primes and patterns and polygons and palindromic numbers. There's lots of patterns. All right, so you're starting to get it. We're going to take those patterns and swap them in for the words. And after I'm done building it, you get to play it. How cool is that? But how are we going to build it? I mean, we could just code it. Blech, that's boring. Why code it when we could build it in a graphing calculator? Enter Desmos. Desmos is an online graphing calculator where you never have to hit enter. It just automatically calculates whatever you type in. And that is its superpower. Even for values that are changing, the graph updates instantaneously. This unlocks sliders and timers and steppers and buttons, oh my, and so much more. Pair that with the ability to upload and adjust images, and you have yourself quite the powerful platform to build on. And the best part? It's all just math. My favorite way to teach and learn is through hands-on exploration. There is no better tool on this planet for exploring math than Desmos. And with a little bit of practice, there's truly unlimited potential to what you could create using Desmos. But today, I want to build patterns. So where do we begin? Oh, okay. We got a long day ahead of us. I say let's get started. All right, so a few simple things to start with here. We're going to start with a folder, and we're just going to kind of identify our viewport, or kind of the area we're working within here. All right, the viewport defines the width and height of our graph. It just bounds the window between -10 and 10 in the x direction, and then 9/16 of that in the y direction. I went ahead and turned off the grid and axes, but they're still active. They're just like hiding in the background. All right, well, we've got a viewport, so we've got like the skeleton to this whole creation here. I think it's time we make our 4x4 grid where we're going to place our 16 tiles. To create a tile, I determined a center point and then plotted 4 points in a square pattern around that point. Desmos can take a list of points and create a polygon for you. We'll replace our tiles with nice images later, but this is great for now. So just out front of these sets of points, I'm going to say P center tiles and just add that into those points I just defined. And voila, we now have a polygon that we can move around on screen. How cool is that? But we only have 1 tile. We need 16 tiles. Here, spacing out a 4x4 grid with a specified center point. I multiplied by a scaling factor to space out the points kind of how I want. And we now have a 4x4, 16 element grid that's centered about a point that I can maneuver around and put wherever I want. How amazing is that? Let's go ahead and lock it back in at 0,1. Now just got to add our tile polygon to our new 4x4 grid of points, and oh my gosh. All right, cool. We have 16 tiles sitting on our 16 points that we just defined, all lightly spread out, and this is starting to look a little bit like Connections. And let's go ahead and make a folder for our buttons. Okay, and if we recall, we got 3 buttons, a shuffle, a deselect, and a submit button. So let's go ahead and get those points. So similar idea to the 4x4 grid, but just making an even simpler 1x3 row of points. And let's make our buttons a little bit bigger just so we can see them. Nice. So we've got 3 spots for buttons. We've got 16 tiles. This is looking pretty good. And now for the true fun of the game. So for patterns. So for patterns, the end goal is for the game to create lots and lots of patterns. So y'all can play lots of game boards. But for now, we're just going to hard code in like 4 patterns to start with. So for the easy pattern, I just went arithmetic. So like adding 4 each time. For intermediate, we're doing geometric. So multiplying by 3 each time. For advanced, we're going to do a prime factorization of 385. So 5 times 7 times 11. All primes that multiply to 385. And for creative, the extra fun one, how about we make use of binary numbers? So we'll do 1, 2, 3, and 4, but written in binary. How cool is this? This is crazy. We're using pure math to structure and lay out this world, this creation that we're making for ourselves using only mathematical relationships in the Desmos graphing calculator. God, I'm so excited to finish this, but it's going to be like 8 more hours. All right. 8 hours was an underestimate. Okay, cool. So we've got numbers. Let's get them on these tiles in some sort of shuffled manner. So just making use of Desmos labels, allowing us to plot our list of 16 game numbers on the 16 tile centers. And look at that, we've got our patterns. A couple glaring issues with this. First of all, make the text a little bit bigger, maybe like a 2. Okay. Second of all, it's already solved for you. 1, 10, 11, 100. 5, 7, 11, 385. 3, 9, 27, 81. 4, 8, 12, 16. Okay, very cool. So it's not a very fun game if it's already organized for you. So we need to shuffle this thing up, eh? That we do. Luckily, Desmos has a shuffle function as well, along with a sort function, which will help us kind of reverse engineer our shuffling later on to check our correctness. And now, wow. So we have shuffled tiles. We have the values that correspond to them labeled on top. Wouldn't it be so cool if we could click on these? So what we're playing with now are the actions. We're setting up how we want the game to respond when different buttons or tiles are clicked. Starting with the tiles, we'll make a 16 element list of zeros and then flip them to ones if their corresponding tile gets clicked. Okay, hopefully that makes sense. So now, when we click on the 4, which should be the first element to show up here, 4, and then I click it again, oh, we go back to 0. Oh, amazing. We got a light switch. That's so cool. Giving the tiles a color change if they're clicked, a nice like visual cue. Also going to limit my is selected list to a max of 4 ones, so y'all can't like select more tiles than necessary. But now we can click 1, 2, 3, 4. Now we can't click anymore. Simply because we're not allowing that click once 4 are selected. We're killing it. We are killing it, but still a lot of issues yet to discover. Starting with this detour, as I encounter issue number 1. Trying to juggle 2 important 16 element lists. We have L patterns, it's like the number patterns in order from easy to hard. And then we have L shuffled, the actual shuffle order of the numbers appearing on the tiles. In this case, from bottom left to the upper right. L shuffled helps us display and tap through the game board without giving away answers, but L patterns is what we'll use later on to evaluate whether or not a pattern was found. So I think we're in good shape now. Look at that. Oh my gosh. And I can't click another 4th one, but I can unclick those and then I can deselect all. Cool. This is looking freaking great. I say we keep going. I think validation feels like the next obvious step now that we're able to click through and interface with the game, because once we can validate, and then we can submit. Ooh. So like mentioned before, we sort our L patterns list by L shuffled to compare the tiles that are selected to their actual position in L patterns. And voila, it tells us we have 4 selected in the 3rd puzzle, which means that we're going to get a 1 for I solved in the 3rd spot, which means that we're going to get a max of this list when multiplied by 1 to 4. If we don't take the max, it's just 0, 0, 3, 0. So we will take the max and it's going to give us a 3, which tells us which puzzle was solved. And maybe I can get a 4 now by doing 1, 10, 11, 100. So now the 4th puzzle is solved. Wow, that's pretty cool. Let's go ahead and get our shuffle working for now to get these 2 kind of pre-submit buttons working. Yep, so now that we can fluidly go back and forth between our shuffled and pattern lists, we can add a seed to the shuffle. A seed is just a helpful number to reset the shuffle function. If this seed number changes, the shuffle randomizes again. So L shuffled goes to L next shuffle, and I selected goes to I next select. We already put that in there, amazing. And then our seed increases by 1. So 12, 8, 24, and 7, come on, shuffle. Hey, 12, 8, 24, and 7. Shuffle, and then we can just keep clicking. Shuffle, 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 shuffle. 12, 8, 7, and 24. Then, yeah, you can hover over your 4 selected because you can't select another one. And then once you deselect it, now we can just start tabbing through the board. And none the wiser to what the actual pattern is, but it's okay if I just shuffle, shuffle, and shuffle, and shuffle. And then let's just go see for fun, is our validation correct? Look at that, it's telling us we have our first pattern correct. We are on to something. This game is going to be done by the end of the day, and y'all are going to get to play it soon. It's so cool. Again, not even close. But we are making great progress. The game is laid out, playable. Now it just needs to do something when you hit submit. So, on to feedback. I think it's time we jump into the animation timers. It's going to make it a lot more interactive and engaging and playable. So let's take a quick peek at connections, and let's start with incorrect. We'll get to correct in a second. Let's just start with incorrect for now. So if I were to pick 4 incorrect answers, or I mean, assuming they're incorrect, because I plucked them randomly, we get a nice little lift and we get a wiggle. So the lift seems to be assessing it, whether it's right or wrong. And then if it's wrong, it gives us this little wiggle. Wiggle time. So, okay, just adding a new animated point to the 4 selected tiles. I modeled the lift as like a small little parabola and just used sine for the wiggle. We use timers that scrub from 0 to 1 to quickly cycle through the animation. But of course, easier said than done. Adding this effect to the polygon tiles proved difficult. So I figured it was time to go into Figma and create some basic assets for the tiles to replace these graphed shapes. Figma is fantastic. It lets you do a lot of intermediate and advanced stuff in simple ways. And as someone who does not have a background in graphic design or anything like that, I use Figma to create quite a few components for my math activities that I create. So just going to frame up a couple of rectangles, round off their corners. I'm going to do my best to match the connections kind of off-white color along with the dark gray tiles to show the ones that have been selected. Look at that, so beautiful. I love math. I've never been so excited to get a wrong answer. Ran into another issue with the selected tiles having their labels swap all around. I eventually solved that by unshuffling the labels, but then just relabeling the tiles with the original shuffled list. Yeah, sometimes you just gotta twist some knobs until you find the right combo of math expressions. What's great about this now is I should be able to shuffle and it should all stay. Yes. Yes. The labels aren't changing around. Can't select a 4th one. Oh my gosh, it's working. Yes. So now that we can animate a wrong answer, it's time to set up our timers. In this case, we're driving our main time through the use of a ticker. The ticker in Desmos runs off your computer clock and ticks by on the order of milliseconds. So using this ticks, we can not only add time to our timer, but also decide to run actions well after the timer's already started. So here, we're going to be able to run the animation for an incorrect answer, and then when the animation's over, we can automatically reset the board to just be playable again. And things were looking so good, I just had to jump over to Figma and create some assets for the buttons to bring it all together. And speaking of buttons, what happens when you click submit with a correct answer? We'll worry about the auto solve when that time comes, but for now, let's see if we can't get the feedback proper for when we correctly do identify a pattern Sorting. Gonna need a new folder. And thus began my long journey into sorting these tiles into correctly solved groups. There's a lot of nuance here. There's 4 available patterns at the start of the game. So like any given one could be the first solved and thus be animated to the top row, just like in Connections. So take whatever solved pattern that is selected, wherever those tiles are, and swap them with any unselected tiles in the top available row. My solution was to have 2 lists at any given time. One list with the current state of the game board and another that swapped the last 4 elements of L shuffled with like our 4 selected tiles. There's some fancy notation you can parse through, but the end effect was just like a timer that animates the tiles from an initial state to a newly sorted end state. This didn't come easy. I kind of had to sleep on it. All right, let's see here. So let's do a reset. When I click on these 4 numbers that are in a pattern, they should organize to 7, 24, 25, 56, the order I put them in my L patterns list over here. And with that being said, the 27, the 3, the 4, and the 81 should fill these 4 spots that are left vacant. Let's give it a shot. Oh my gosh, it's perfect. Okay, perfect might be a bit of an exaggeration. We got the first row to sort, but they're still selectable after sorting to the top. We want the solved row to like disappear behind a card that explains its pattern. And more importantly, like disables those tiles from being selected again. I hopped into Figma again to create these solve cards and use the RGB readers in my eyes to determine the exact color matches. I'll also note the main pattern that I'm working with is the sum of a Pythagorean triple. 7 squared plus 24 squared is 25 squared. And the sum of those values is 56. That's cool, huh? So why did I swap that in for the prime factorization sequence? And why didn't I notice the mislabel for hours following this? 4 times I solve card 1. Let's just hit submit and see what happens, eh? Whoa! Holy. It just worked. I was not expecting that. I was genuinely not expecting that to work. Oh, should we go for it? How crazy would this be? There's no way, right? There's no way. This is going to break. I'll take it. That's pretty good. There's just something about solving math problems that is so delightful. And luckily for me, there's many more to come my way. Starting here by creating an end state to the game so the final tiles don't disappear. Once we figure that out, we'll be able to hide the buttons and replace them with like a new game button. Oh, it's looking so good. That's so exciting. 4. And then these should self-organize. I think I already watched this through. It's very satisfying. It's just very satisfying to do a bunch of simple math and then suddenly this dream that you've been developing and creating in your mind is just like playable, is actionable. Oh, how sweet. But I mean, this thing, it looks like Connections, right? It's just missing the attempts counter. So just made quick use of a point list to mock that up and boom. On to sorting these tiles when a correct pattern is submitted. Boom, reset ticker, select those 4, submit, boom, we're in. So, with that being said, I spent the next few hours trying to find the solution and then gave up and went to bed. Then spent more hours in the morning watching my game board devolve into madness. The solution came down to a 2-stage animation trigger. So stage 1 starts the moment the last incorrect attempt is submitted. The incorrect wiggle animation shows, then the moment the animation is done, stage 2 triggers. If you have multiple attempts remaining, stage 2 just resets time to 0, re-enabling the buttons and takes an attempt away. But in the case of the final attempt, we want stage 2 to act differently. We still want to reset time to 0, but then automatically select the next pattern of 4 numbers and just start time again. This will create a nice automated cycle so we can use all the feedback animations and logic that we built before, but to just automate this kind of solve process for the last attempt of the game. Okay. Now let's run the real test here. scared. I don't want to do it. Oh my god. Ah! It works. It works. So exciting. And sorry I had the camera off. You didn't get my full reaction. Once day 3 turned to day 4, turned to day 6, I just kind of stopped recording myself, you know, staring blankly at a screen. But what a breakthrough. We now have a fully functional game that can like survive all instances of a single playthrough. We're on to the final step, adding in more patterns so new games can be generated. So here's the breakdown. I want to create 25 different puzzles consisting of a variety of different number patterns: easy, intermediate, advanced, and creative. For easy, I wanted to keep it super simple, so I just went with like arithmetic sequences and even and odd sequences. You know, there should kind of always be a gimme. For intermediate, I stepped it up with geometric sequences, prime number sequences, perfect squares, and perfect cubes. For advanced, I just had to bring in the Fibonacci sequence, just a simple recursive function in Desmos, and boom, Fibonacci sequence. I also incorporated prime factors and factorial sequences, both of which can result in some large numbers, hint, hint. I finished it off with triangular numbers, where the gap between numbers grows by 1, and finally, the sum of Pythagorean triples. The advanced pattern can be quite the challenge. And then there was creative. This is where I let loose a bit. You've already seen the binary sequence, but I've been doing some thinking. I added palindromic sequences, upside down numbers, Roman numerals, critical temperatures, and quite a bit more, but come on, I'm not going to spoil all the surprises. But even on that cliffhanger, why am I giving any of this away? If you made it this far in the video, come on, you deserve a little insight into the making of the patterns. Just go impress your friends with how good at math you are. All right, finally, for real, on to the last stages of this build. I had to create this huge table to test my 25 different combinations of game board puzzles and make sure there was no shared numbers. It didn't feel very Connections-like to have repeat numbers on the board. Then I just had to create the labels for the corresponding 25 game board solve cards, you know, like the things that explain the 4 different number patterns in a sentence. And the final exclamation point was adding the new game button, so whether you successfully solve a puzzle in your 4 attempts or not, you just get another try. Get a new game. There's always more math to explore. So enjoy as I polish the final details, and please go play the dang game. It's free. Anyone can play it. Okay, go. Oh, we did it. Connections, but math. This was like my first ever attempt at making a video, anything like this. So please, if you liked it, go like and subscribe. But most importantly, go play the game. Link in the description below. If you're feeling extra nerdy, you can hop into the second link and go edit the code. Customize the game however you like, or use it to inspire your next build. Okay, see you all in the next one. Love you, math. Bye.